Okay. Well, good evening, everyone. We're really excited to have you here for our webinar, Stay Cool, Stay Warm, Heat Pumps Demystified. And a big thank you to the City of Eden Prairie for sponsoring this webinar and making it possible. My name is Matthew Douglas May. I'm here with my colleague Jason Clay. We work for the Center for Energy and Environment on our Electrify Everything Minnesota program. And this program, the goal of our program is to support the gradual electrification of single-family homes by providing education, resources, and support to make it happen. And this Electrify Everything Minnesota is a collaboration between the Center for Energy and Environment, the cities of Eden Prairie, Edina, St. Louis Park, Minneapolis, Rochester, and Hennepin County. So we're really excited and grateful to have so many great partners in this work. Next slide. So tonight we will be focusing on heat pumps and insulation, how you heat your home. But a week from today, on Monday, we'll have another webinar sponsored by the City of Eden Prairie on water heating, cooking, clothes drying, and electrical panels as well. So if you haven't registered for our webinar next week, we would encourage you to do so. I just put the link in the chat here. And yeah, that'll be part 2 of our series. Next slide. So, like I mentioned, tonight we're talking about heat pumps. So we're going to start with kind of a welcome and grounding of why we're talking about this. Then we'll jump into different types of heat pumps, how they work, why insulation and air sealing are really important for making sure heat pumps work as well as they can. Then we'll talk about how you can decide which heat pump may be right for you and your household. And then 3 key questions to ask contractors when you're getting bids. And then we'll wrap up with financing for heat pumps and costs and some resources that are available to help you make an upgrade possible. And then we'll have a question and answer time around 6:50 where we'll get to dive into your questions. Next slide. And we want this to be an interactive webinar. So please put your questions in the chat as we go along. We're monitoring that closely and we'll answer clarifying questions at the end of each section of our presentation. And then we'll be sure to answer the kind of larger substantive questions in the Q&A section at the end. So yeah, please put your questions in as you think of them and we will be sure to address them all. And then last but not least, we will be sending out the slides from this presentation with all the links. So you'll get all the resources we talk about and have a copy of all the information we cover. Next slide. So with that, let's jump on in. So what are the benefits of heat pumps? Why are we talking about home electrification? Next slide. So when we're talking about home electrification, we're talking about switching the main users of gas in your home over to electric options. Excuse me. And tonight we'll be focusing on weatherization and your heating system. So how do you heat your home and how do you keep that heat inside your home? But the other key areas to address when electrifying are your water heating, your clothes drying, and your cooking. And we'll be covering those along with electrical panels at our next webinar a week from today. Next slide. And the reason we focus on these technologies, these appliances in your home, are that one, they're the largest gas users in a typical home, and they're also just the largest energy users. So here in Minnesota, we have really cold winters, and as a result, 72% of all of the energy used in the average Minnesota home goes towards heating. That's significant. So when we're thinking about cutting carbon emissions and or becoming more energy efficient, the biggest bucket to focus on is your heating system and insulation. Water heating is next, then air conditioning, and then everything else. And we'll talk about those next week. Next slide. And one of the big reasons why electrification is on a lot of folks' minds is that it is a really clear path to reducing your carbon emissions. So the Minnesota electric grid is currently 54% carbon free, and it's on a path to be 100% carbon free by 2040 thanks to state law. And Xcel Energy has made additional pledges. They're on a path to achieve 80% carbon-free electricity by 2030. So that means, an appliance installed today in 5 years, it'll be using 80% carbon-free electricity, and you have the option to add additional renewables onto that if you want. But it's a really clear path to reducing our home's carbon emissions, which make up a really big portion of carbon emissions in the state of Minnesota. Next slide. So, what are some of the benefits of heat pumps? Tonight we're talking about heat pumps specifically. And I would love if everyone who's here in the chat, if you could just list, what are a couple of the benefits of heat pumps you have heard about? So I'll give everyone, 20 to 30 seconds to type in a quick answer. What are some of the benefits of heat pumps? I'm seeing no direct emissions from David Butler. Yeah, spot on. Very energy efficient. Yeah, thank you, Peter. Great. So yeah, keep those coming in and we'll reveal what we see too. Yeah, one appliance to heat and cool. You guys are predicting exactly what we've got coming up. So yeah, there are a ton of benefits with heat pumps. They both heat and cool your home. They're better for the environment, the fewer emissions. They're super energy efficient, about 3 times more efficient than traditional heating systems. They reduce or eliminate combustion gases for heating your home, which can help your health. They maintain consistent comfort levels and they operate really quietly. So as we go throughout today, we're going to talk about how heat pumps work, and these benefits will become clear, the why behind the benefits. Next slide. And before we jump into things, I wanted to ask everyone, what are your motivations for switching to a heat pump? You're here spending your Monday evening with us to learn and chat about heat pumps, and would love to hear, what brings you to this webinar. Do you have like a really old furnace or boiler that needs to be replaced soon? Are you interested in helping the environment? What's your reason for joining us? So throw that in the chat, and then we'll jump into it. Yeah, this is from Peter. My furnace needs to be replaced. Want to get rid of gas in my house eventually. That's great. Yeah, David just wanted to learn. From Chris, want to gain a general understanding of the technology. Awesome. Cool. Yeah, keep those coming in. Oh yeah, very old air conditioner unit. See if there's benefits. Awesome. Environment. This is great. So yeah, keep those coming. Keep putting your questions in the chat and we will yeah, we'll keep moving on. Next slide. So today we're going to talk about the 3 key decisions you need to make to choose which heat pump will work best for your home and how to choose the right heat pump for your household. And the first decision is what type of heat pump system. Next slide. So to lay the groundwork, what are heat pumps? Heat pumps move or pump heat from one place to another. Because they move heat instead of creating it, they're very energy efficient, and they can both heat and cool your home. It's a similar technology to a refrigerator or an air conditioner. So in the summertime, a heat pump will move heat from inside your home to the outside to cool it down. And in the wintertime, it'll do the opposite. It'll move heat from the outside, even when it's cold, into your home to heat it. Next slide. And they do this through refrigerant. So their air source heat pumps have an outdoor unit, which in the wintertime, it'll pull heat from the outdoors, move it through refrigerant lines to the inside of the home, and then distribute that heat that way. Next slide. So there are three main types of heat pumps that we'll talk about, but today the vast majority of the presentation will be focused on air source heat pumps. So air source heat pumps transfer heat between the outdoor air and the indoor air. The pros of this are they're very energy efficient, like I mentioned. And really the big advantage of air source heat pumps are they are super flexible and they work in most homes and are compatible with most existing HVAC setups. So they're really widely applicable and can be installed in most homes. They have the lowest upfront cost of the heat pump technologies, and they're widely available with a lot of contractors who are experienced with installing them. One of the cons is that their efficiency decreases as the outdoor temperature gets super cold because there's less heat to pull out of the air. Next slide. And on the topic of flexibility, there are two main heat pump system types. There's a ducted system where you've got your outdoor condenser that would replace your central air conditioner, and it connects into the ductwork in your home through the air handler and then moves the heat and or cooling throughout the home through your ductwork. The other option works well for homes that have boilers or electric resistance heating. It's called a ductless or a mini split option. On the right here, you see these mini split heads. Those are mounted in multiple rooms throughout the house, and the heat is distributed through that. And all of those can be connected to the outdoor condenser. So because of that, these work in most homes. Next slide. Another type of heat pump system are ground source heat pumps. These are also called geothermal heat pumps, and they transfer heat between the ground and the indoor air. The big pro here is they're super energy efficient because the ground maintains pretty much the same temperature year round. They can be about 4 times or 400% efficient. The main con with these is that they have a very expensive upfront cost, and because you have to lay the underground piping, most homes in cities or suburban areas don't have the land or amount of land needed to install these pipes, or there are a lot of excavation logistics that get in the way. So they can be hard to install and not available to a lot of homes, especially in metro areas. But yeah, the cost is usually the biggest barrier. Next slide. And then a third type are air to water heat pumps. So these transfer heat between the outdoor air into an indoor hydronic or water distribution system. So the big advantage here is it can provide radiant heating. So say you have in-floor heating from a boiler, this can plug into that. But the cons are that, again, these have a high upfront cost because they're a relatively new technology. Because they're new, they also, it's really a case-by-case basis that if it'll work in your home or not, and they aren't compatible with old radiators. You would need a new hydronic distribution system like in-floor heating. Next slide. So, I just talked about the three types of heat pumps, and moving forward, because air source heat pumps are the most applicable to the largest number of households, when we say heat pump moving forward in this presentation, we'll be referring to air source heat pumps. And with that, I'll pass it over to Jason.
Thanks, Matthew. So Matthew discussed a bit about heat pumps and how they work, and we're going to dive into a little bit more of the details. So basically, a heat pump, it's in the name. It pumps heat from one area to another through a refrigerant. It's like a two-way air conditioner. And when we speak of air conditioning, we often think of AC units and cooling, but in this case, we're describing a way to control the humidity, ventilation, and the temperatures within our home. So on the left-hand side, you can see that the heat pump is operating in the summertime. It's transferring heat outside to cool the home. And on the right-hand side, it's running in reverse in the wintertime to heat the home, and it's transferring heat from the outside inside the home. So there's two main variables in the operation of a heat pump, and those are heat and pressure. And one easy rule to keep in mind is that heat moves to cold. So heat has a natural tendency to move from warmer areas to cooler areas. And in this case, this is how the heat pump operates to move heat from the outdoors or the indoors to the different area. Um, the other variable is pressure, and pressure changes the temperature of a substance. And in this case, the substance is the refrigerant in the refrigerant lines. And so when you raise the pressure of the refrigerant, it increases the temperature. And by lowering the pressure of the refrigerant, it lowers its temperature. So this is a simple diagram of how an air source heat pump operates. On the left-hand side, you can see it's representative of the outdoor ambient air. The right-hand side is the indoor conditioned air. At top is the compressor, and the bottom is the expansion valve. And so the first step is the air is going to flow over the outdoor coils. That very cold refrigerant is going to pick up the ambient heat from the outside and move that indoors. The next step is that refrigerant that's got that heat from the outdoor air. It's going to move up to the compressor where pressure is applied to the refrigerant. It's going to increase the temperature of the refrigerant to approximately 120, 140 degrees. And that heated refrigerant in the third step is going to move to the indoor coils, and it's going to eject the heat into the indoor air and thereby heating your home. So the final step in that process is the refrigerant. Once it's released the heat into your home, it's going to move to the expansion valve. Expansion valve is going to decrease the pressure of the refrigerant, thereby decreasing the temperature, and then the cycle is going to begin again. We're back to the start where that refrigerant is going to absorb the heat from the ambient air. It's going to move it to the compressor, increase the pressure, deposit that heat, pump the heat into the home, goes to the expansion valve, the refrigerant is cooled, and the cycle goes through again. Now, Matthew's going to talk about the importance of air sealing and insulation.
Awesome. Thanks, Jason. Yeah, so that was a quick overview of how heat pumps work, and I'm going to talk about why insulation and air sealing are super important to make sure your heat pump works as well as it can. So insulation and air sealing refers to making sure you've got enough insulation in your walls and your attic, and then sealing up all of the air leaks in your home, like around light fixtures, attic hatches, bathroom fans, anywhere where conditioned air can escape. So insulation is really important, and air sealing are really important for keeping the heat inside your home during the winter months and keeping the heat outside your home during the summer. Next slide. So why is insulation and air sealing important for heat pumps? Well, if your home is properly insulated and air sealed, your heat pump won't have to run as hard and the inside temperature is easier to maintain because you won't be losing as much of that heat that your heat pump is putting into your home. So this will save you money on your bills, regardless of what type of heating system you have. It's insulation and air sealing is one of the most cost-effective projects you can do to your home because of the really significant energy bill savings. And the big advantage is that when your home is properly weatherized, which is another word for insulated and air sealed, your heat pump will be able to fully heat your home for more of the winter. Next slide. And here's a graph to demonstrate that last point. So heat pumps are most efficient in milder weather when there's more heat in the outside air to extract. But when we get really cold, down to, like 5 degrees to -15 degrees, the heat pump efficiency reduces and it can provide less heat to the home. Next slide. So what this means is that in the orange example, which is an unweatherized home, it has not enough insulation, it's really leaky. In that home, this example heat pump could provide all of the heat that that home needs down to a 20-degree outdoor temperature. When it's below that temperature outdoors, the heat pump cannot provide enough heat to the home. However, if that same exact home gets insulation and air sealing and is properly weatherized, it has the same heat pump, same home. It can provide all of the heating that that home needs down to 5 degrees. And we'll see in a little bit that really the vast majority of the winter we spend above 5 degrees. So it's a big difference if your home is weatherized. It means that you can use your heat pump a lot more of the year and it'll be a lot more efficient. Next slide. So that brings up the question, can a air source heat pump do all the heating that my home needs? Next. And the short answer is typically no. In Minnesota, it's actually required to have a secondary heating system and to provide booster heat for the coldest weather. And this can look like having a gas furnace or boiler, or an electric plenum in your air handler, or electric baseboards. And we're going to talk about, even though you do need secondary systems, how those can work with your heat pump and why it's still a really good idea to have a heat pump. Next. And over to you, Jason.
Thanks, Matthew. So as Matthew mentioned, the next decision that you want to consider when you're thinking about air source heat pump is what type of secondary heating system you want. And first of all, we're going to talk about what the secondary heating source does in really cold weather. As you know, living in Minnesota, we have a very cold climate. And so having a secondary heating system helps us maintain a steady temperature throughout the year, throughout the different seasons. As Matthew mentioned, as the temperature drops, the air source heat pump is able to deliver less heat as the outdoor air cools. And so once that outdoor temperature reaches a certain point, the air source heat pump, it's not going to be able to deliver enough heat to keep your house comfortable and at its set point. Another thing that it does in the wintertime, particularly it helps keep our energy bills in check. Natural gas equipment is generally cheaper to operate than a heat pump in very cold weather. And that's sort of an outcome of natural gas per unit being cheaper than electricity, generally. So a heat pump can partially or fully electrify your heating needs. And so you have two options when you're considering your secondary heat source. That's hybrid or an all-electric system. So in the hybrid system, what it essentially is you're using a heat pump paired with a fossil fuel system, for example, a natural gas system. And the benefits that it can essentially keep your energy bills neutral or lower, and it still, in spite of using partial fossil fuel system, it still significantly reduces your carbon footprint and your household carbon emissions. The one drawback is that the setup can be complicated. It depends on a variety of factors, the existing equipment in your home, and what sort of heat pump you decide to get. So that's definitely something you would need to consider with a hybrid system. Your other option is the all-electric system. And essentially, this is all electric. It's a heat pump paired with an electric plenum, which is essentially the device that attaches to connects your ducting with your air handler. And the benefits of this is can be far easier to set up. It's usually an integrated system. You're not trying to configure different energy sources and different setups. And an all-electric system obviously it's going to have the most impact on reducing your carbon footprint and the carbon emissions of your household. The one drawback, again, going back to what I mentioned about electricity being more expensive per unit, is that your winter bills are almost always going to be more expensive. And as well, with an all electric system, you will need a cold climate heat pump. So you may ask if you still need a secondary heating system, how much are we really using the heat pump for heating? So we have some charts here, and this first chart shows the heating hours in a typical Minnesota year. And you can see when it's in the low 60s, we're operating at about 700 hours approximately. Up when it gets to the 30s, we're getting up to almost 1,400 hours per year, and then it drops down dramatically as the temperature cools. So the highlighted section of this graph is demonstrating that most of our hours of operation are in the mild to moderate cold. And then this graph is just showing that, we comparatively, we have far less operating hours in the severe cold. And so what does this mean for air source heat pumps? If you have an air source heat pump with a 40-degree Fahrenheit switchover, the heat pump is essentially going to cover approximately 40% of your heating hours. And you can see that highlighted in orange on the graph. And if you have a heat pump with a 20-degree Fahrenheit switchover, the heat pump significantly increases that coverage to approximately 80% of the heating hours for the year. So why would you want a heat pump that can cover more of the heating season? As you can see from that graph, there's a lot of benefits to that. You're going to be using the heat pump longer part of the season. You're going to have more consistent temperatures throughout your house, especially in the shoulder seasons. Air source heat pumps going to improve your air quality, saves wear on the furnace. In mild weather, you don't have a constant cycling on and off of the HVAC system, and it still will inevitably reduce your carbon emissions of the household. Now I'm going to pass it to Matthew to talk about what kind of heat pump will work best in your home.
Yeah, so here's a decision tree that can help you figure out what type of heat pump will work in your home. So start with your existing system. Do you have a furnace, boiler, or electric baseboards? Next. And then thinking about the type of heat pump you want to get, are you going ducted or are you going ductless? So if you have a furnace with ductwork, then you're going to go with the ducted option. And you can go hybrid or all electric there. If you have a boiler or electric baseboards, you'll go ductless, those mini split options. And you can go hybrid with a boiler or all electric with electric baseboards. Those are most common. Next. Yeah, and then for thinking about your secondary heating system, if you have a furnace and you want to do the hybrid option, you can either install a new furnace with your heat pump, or if your furnace is still relatively new and is compatible, you can sometimes keep your existing furnace and just install a heat pump to replace your central air conditioner. So those are the two main options for a hybrid system. If you want to go all electric and you have a furnace, you'll completely remove the furnace and replace it with an air handler that has electric heat strips as the secondary system. If you have a boiler or electric baseboards, it's most common to keep those existing systems in place as your secondary heat source, as long as they're working, and then have mini splits as your main heating source. So that can be, a simpler and cost-effective upgrade to just keep your old system as your secondary. Next slide. Right, and now I'll get to that third decision, which is what efficiency level or compressor type do I want? And this is really, how efficient, what tier of heat pump do I want? Next. So there's two main categories of heat pump compressor efficiency. The first is standard efficiency. So these are single stage or two-stage compressors. What this means is they've got they're either on or off, or they are off, low, or high. So there's just, one or two modes. These are good for heating and shoulder seasons because they're less energy efficient, but they're also less expensive up front. The other type of heat pump are called variable speed heat pumps, also called cold climate heat pumps. And these adjust their speed in many small steps. So they can modulate how much heat they're providing in the winter or how much cooling they're providing in the summer, and really small steps to get you exactly as much heat as you need, not more, not less. So these are great options for heating below freezing temperatures. That's why they're called cold climate heat pumps. And that variable speed ability is really needed if you want to do most of your heating in the winter in Minnesota with a heat pump. Before rebates and tax credits, they are more expensive upfront, which is the main consideration most folks are balancing when they're getting quotes is, do I go with this more expensive variable speed option or the cheaper standard efficiency option? Next slide. Some of the advantages, or one of the big advantages of variable speed heat pumps are that they provide really even heating and cooling. So this blue line shows a single stage heating system where it's blasting the heat on to heat up the home, and then it cools down, and then it blasts heat again to heat it back up, and then it cools down. Um, but a variable speed system can just provide a small amount of heat really consistently to keep that window of temperature much narrower in your home and maintain a consistent temp. Next slide. Some other advantages of variable speed heat pumps are that they're more energy efficient. So you'll have lower bills compared to a standard efficiency heat pump. They're better at dehumidifying in the summertime when they're in cooling mode because they have longer run times. They're running at a lower speed for longer amounts of time. They can pull more moisture out of the air. They are quieter when they're operating at lower speeds, which can be nice. And then one big one is that they provide flexibility and future proofing against rates. So if you have a hybrid system with a variable speed heat pump and a gas backup, say gas prices go up in the future, you can have your switchover temperature to your heat pump be lower so that you can use it for more of the year, and that would actually lower your bills. So it provides you more flexibility and control for future changes that we can't predict. And then last but not least, they usually qualify for higher incentives because they're more energy efficient. So sometimes you can get these variable speed models for the same price as a lower efficiency model because of incentives. Next slide. And then a really important question to ask is, will a heat pump save me money on my energy bills? And unlike a traditional efficiency program where you're just replacing, an inefficient gas furnace with a more efficient gas furnace, it's a little more nuanced here because we're switching from gas to electric. Next slide. So the Minnesota Air Source Heat Pump Collaborative, which is operated by the Center for Energy and Environment, does a cost of heat comparison, and it provides some really interesting insights. So this scenario is using Xcel Energy's standard electric rate, and what we see on the left here is the baseline. So if you have a gas furnace, the heating cost is in orange, and then a traditional air conditioner cooling cost is in blue there. So you can see the annual heating and cooling cost is about $1,300. If we have a hybrid system with a heat pump and a gas furnace backup, and the switchover temperature is 30 degrees, your bills will be about the same. If you have a 15-degree switchover temp, bills are, a couple hundred higher. And then if you go all electric, you can see at this rate, your bills will be about $1,000 higher in the winter in this scenario. Next slide. Um, and the good news is that Xcel Energy has an electric space heating rate. So that means if you heat your home with electricity, like electric resistance or a heat pump, even a hybrid heat pump with a gas backup, you can qualify for this rate and you'll get about 3 cents per kilowatt hour less will be your rate in the wintertime. So with that rate, you can see that a heat pump will actually save you money compared to heating fully with a gas furnace. And the big difference is that all electric cost goes way down. It's only about $300 more winter as opposed to about 1,000 with this all electric rate. So we'll talk later about um, how to get on that electric rate when you get a heat pump. Next slide. So to summarize, will a heat pump save me money on my energy bills? If you currently heat with natural gas, cost parity is the goal. The goal is to have your energy bills remain the same or save a little bit. If you have a hybrid or also called dual fuel system, you can expect your bills to stay the same or go down a little bit. Um, if you have an all electric system, that will likely increase your bills. If you currently heat with propane or electric resistance, a heat pump will lower your bills. That's because propane is really expensive and electric resistance is super inefficient. So in both those cases, a heat pump will save a ton of energy and or money. Um, yeah, and then another important consideration beyond cost is, will a heat pump really reduce my carbon emissions? And like we mentioned earlier, the electric grid in Minnesota is on a path to carbon free. So tying your heating system to that is a surefire way to reduce your home's carbon emissions. And you can go beyond right now with renewable energy subscriptions or rooftop solar. But you don't need to because, necessarily because the electric grid is getting cleaner. Next slide. So what this means is if you have a hybrid heat pump system where you've got your heat pump providing heating and then you have a gas backup, you can achieve a significant decarbonization. If you think back to that slide that Jason showed, where if your switchover temperature is at 40 degrees Fahrenheit, about 40% of the heating hours are covered by your heat pump. In that case, you're achieving, a moderate decarbonization. But say you have a hybrid system and your heat pump as switchover temp is 20 degrees Fahrenheit, you're covering 80% of all of the hours in the winter that you're heating your home, your heat pump is doing that heating. So that's a really significant decarbonization. And then if you go all electric, you can achieve full decarbonization, 100% carbon free. Um, And then, yeah, just we'll answer a lot of these questions at the end, but is there a cost comparison for a heat pump versus an AC? In that last graph there, it's hard to see, but a traditional AC could be about, a $280 annual operating cost, and a heat pump might be about $200 annual operating cost. That's the numbers behind that graph we showed. So heat pumps are more efficient air conditioners, basically. All right, next slide. And with that, pass it over to you, Jason.
So now we're going to talk about making the decision of what you want to go forward with, and it's going to be based on your primary motivations. So key heat pump decisions. These are things you want to consider. The first one is what type of heat pump do you want and or need? So again, we talked about your uh, various heat pumps with the different set points. Your secondary system is the second question you want to consider. What secondary system do you want to use? Do you want to go all electric or do you want to use one of the hybrid systems? And the third question you're going to want to ask yourself is, what do you want to get out of it? Are you looking for efficiency? Are you looking for decarbonization? You're looking to save money on your energy bills. So those are some of the main things that you need to consider when thinking about getting a heat pump. What kind of heat pump do you want or need? Most economical, you looking at a standard heat pump versus a variable heat pump or a cold climate heat pump. Um, do you have an existing home? What is the current heating system, HVAC system in your home? Are you building a new home? You may want to consider going back to what Matthew talked about, is in a lot of cases it's cost prohibitive to purchase a ground source heat pump. But if you're building a new home, that may be something you want to consider and build into your plans. Want to ask yourself, what do you want for your secondary system? Are you looking for maximum decarbonization? Then you want to go with all electric system. What's going to be most economical? Are you trying to reduce your energy bills and sort of diminish your upfront costs? Then you want to go with a dual hybrid fuel system as your secondary system. And what do you want to get out of your heat pump? What efficiency level are you looking for? Are you looking for maximum decarbonization? In that case, you need the variable speed, and you want to consider all electric. Again, the all electric is going to have the maximal decarbonization effects. Are you looking to save money on your energy bills? In that case, the variable speed is really great. As Matthew mentioned, you don't have that high oscillation in the on and off. You can really dial in um, the system so that it's functioning at sort of even keel throughout the season. And you want to lower your upfront costs. And in that case, you would want to go with a standard efficiency heat pump. Are you looking to just heat in the shoulder seasons? A standard efficiency heat pump would suffice with those conditions. So again, these are just some of the things you want to consider when you're looking at heat pumps. And then the next step is you're going to be looking into contractors. And there's three key questions that you want to think about, have in hand, have in your back pocket when you talk to contractors. And the first piece of advice is kind of as you're thinking about an air source heat pump, you want to figure out your goals and motivation, maybe write them down and really have a good sense of where you want to go moving forward. A customer, you are more likely to get an appropriate quote from a contractor if you're very clear about your motivations, very clear about your goals, what the end goal of installing a heat pump is. Maybe if you have subsequent electrification projects you want to have done, you want to have your contractor be aware of those. Um, and some of the things to consider, are you looking to improve overall comfort? Are you just trying to add additional cooling? Is your major concern electrification and decarbonization of your household and having a reduced impact on the client or the climate? And are you trying to reduce your energy bills? Another consideration. And again, there is an upfront cost of those, and that's something to consider and take into consideration when you're talking to a contractor. So, three key questions to ask when evaluating bids and choosing your contractor each have to do with sizing, existing system and ductwork of your current HVAC system, and what your options are. So, what does sizing have to do with it? A bigger size air source heat pump can do more heating. The pros, it can run in colder weather. The con is that it can have decreased performance in hot weather. With a smaller, right-sized air source heat pump, it's going to cost you less upfront, and it will literally be a smaller unit attached to your household outdoors. One of the questions you want to ask is how do you determine what size heat pump do I need? The contractor should be familiar with air source heat pumps in the first place, be able to speak knowledgeably about them, and with a sort of enthusiasm or interest in the topic, be able to provide you answers pretty readily with the questions that you have. The contractor should be able to use multiple data points to sort of assess the size of air source heat pump that you need for your household. And some of these factors that they would take into consideration would be the square footage of your home, local weather data, etc. To really dive deep, the contractor may offer or you may suggest that they perform a manual J calculation. And what that is just basically a high standard comprehensive way to calculate the HVAC load of your home, including a variety of factors. What the contractor should not do is eyeball your home, your household, and sort of select what size air source heat pump based on that, or experience, or sort of a rule of thumb based on square footage of your home. And they should also not be basing the air source heat pump they're going to install based on the size of the existing HVAC equipment that you have currently installed. Ductwork in your source heat pump. The duct size determines the volume of air that's being delivered throughout your home and the size of your heat pump needed for your home. Another important factor when it comes to ductwork is leaky ductwork. If you have air leaks throughout your ductwork, it's going to decrease the uh, efficiency of your air source heat pump.
And
Second question is,
Jason, I'm gonna just
sure.
jump in quick. We had a
Yep.
question related to ductwork.
Okay.
Um, and it was might a variable speed heat pump require changes to ductwork in an existing ducted system? And if you have a very old home, like pre 1950, with small ducts, that can impact either the size of heat pump you need or heat pump compatibility. So that is an important consideration when getting heat pump quotes. And yeah, over to you, Jason.
Okay. Second question to ask is, will you inspect my ductwork? The contractor should be able to do a visual inspection of your ductwork, describe how your current ductwork impacts the sizing considerations of your source heat pump. They should also ask about your comfort experiences with controlling the climate and the air condition aspects of your home. And they should also be able and willing to perform a static pressure test of your ductwork. The final question that you want to have in hand for contractors is, can you quote me options that qualify for rebates? And Matthew will go into these later, but there's financial incentives and rebates that are available for air source heat pumps, cold climate heat pumps. So the contractor should be providing quotes for products that are eligible for tax and rebates. Um, they should provide bids at various prices, price points, and provide you with the not the incentive eligibilities of those different price points. The contractor obviously should not be completely confused when you ask these sorts of questions, and they should have an idea of what incentives are available for the sizing of equipment that you're interested in installing in your home. Then the bonus question to ask installer, contractors, does my electrical panel have capacity? And this is really important. The contractor should be able to assess your current electrical panel for space and capacity. Um, include needed electrical work in the quote if there are any upsizing that's required for your electrical panel. The contractor should not skip looking at the electrical panel. If you join us at our next workshop, we're going to talk a lot about electrical panels and how that can impact installation of electrical equipment in your home. Center for Energy and Environment manages or works with the preferred contract. Minnesota Air Source Heat Pump Collaborative has a preferred contractor network. And this is a resource you should definitely take advantage of. These are contractors, a list of contractors who are experienced with air source heat pumps, experienced with their installation, frequently install them for customers, and they completed training. So they're sort of verified preferred contractors. So that is definitely a list that you would want to check out. That being said, any contractor you choose to go with, they should be able to answer the questions that we went over, and you should go into the conversation kind of again, knowing what your end goals are, if you have any future plans that you need to account for, and things like that. And we'll turn it over to Matthew to talk about those financial incentives and uh, rebates to get that cost down.
Yeah, so we'll talk about some financial and other resources, and then we'll jump into the Q&A to get all your your questions answered. Next slide. Yeah. So typically we are seeing that heat pump installs, including the heat pump and the secondary system, can range from $12,000 to $24,000. So it's a pretty big range because different homes need different things, and different secondary systems come with different requirements as well. But the good news is, these are expensive systems. Any HVAC upgrade is, but there are some really great rebates available. So, between Xcel Energy and CenterPoint Energy, you can get up to $2,000 total, depending on the type of system you get. And then there's also a $2,000 federal tax credit available. And even despite some of the uncertainty at the federal level, tax law says that any changes made don't apply until the next year. So if you install a system in 2025, we're confident that it should um, be eligible for the tax credit this year. And then later this year, we are expecting the state of Minnesota to roll out the Inflation Reduction Act rebates, which come with income eligibility requirements. You can look those up on our website or the Department of Commerce's website, and those are up to $8,000. And then along with that, the state of Minnesota will roll out a $4,000 rebate match. So for income qualifying families, there's some big rebates expected later this year. Next slide. And just to give an example of what this looks like, here's just a hypothetical scenario for a heat pump install. So a household in Eden Prairie would like to install a cold climate air source heat pump with a gas furnace secondary system. So the system costs $14,000. CenterPoint Energy provides an $1,100 rebate. Xcel Energy provides a $900 rebate. And then the federal tax credit adds another $2,000. So that's $4,000 off, or about 30% savings from the original cost, which is pretty significant. Next slide. The other piece of the pie. So incentives are for the upfront cost, but the operating cost is the big one too. And and the Xcel Energy electric space heating rate is a really big way to do that. Like I showed earlier, you could save anywhere from 100 to like north of $600 a year with this electric space heating rate, depending on how much you're using your heat pump or your electric system. So the way to enroll is to call Xcel Energy's customer service line and say, I would like to switch to the electric space heating rate. Reiterating electric space heating rate multiple times is helpful, and also letting them know I have an air source heat pump. It's important to be persistent and call back if the person you get on the phone the first time isn't familiar with this rate. It is on their website, and you are eligible if you heat with electricity, even if you have a hybrid system. And this also should not cost anything to you up front. No installation is needed at your home. And what this looks like is from October to May, you'll get a discount on all of your electricity usage. And right now, the electric space heating rate gives you a discount of about 3 cents per kilowatt hour. And it was just updated so that in October of this year, that discount will bump up to about 5 cents a kilowatt hour. So it'll get even better. And that's like a little bit less than a 50% discount on your electric rate. So it's really, really significant. Next slide. And then last but not least, wanted to share a few resources to help with this. A great place to start if you aren't sure, how much insulation does my home have or how old is my heating system? A home energy squad visit is a great place to start. They'll do a full assessment and give you a report that'll give you a really clear plan for what to tackle next. And these visits are $100 or less. The other great option is our program, Electrify Everything, provides an advisor service where if you have any questions about home electrification, you can give them a call. Say you got a few bids for heat pumps and you want help making sense of the difference between them, you can send those over. They can help you kind of understand what the differences are. Or say you want to help finding contractors or understanding some of the technical aspects, give them a call or email them, and they're really, really helpful. And it's a free service made possible by the city of Eden Prairie. And then last but not least, that preferred contractor network that Jason mentioned is a great place to start for getting bids from contractors who are experienced with installing heat pumps. Next slide. Yeah, and then last but not least, well, the takeaways we want you to leave with are that there are many benefits to heat pumps. Be sure to insulate your home, make sure it's insulated before getting a heat pump. If your home is built after 1980, it's likely that your home is in good shape with insulation. And if it's after 2000, you're probably definitely in a good shape. But, before 2000, it's good to get an energy audit. Choose the heat pump system that matches your current setup and your motivations. And then ask your contractor questions when you're getting bids. It's a great way to make sure you're, getting the system that's going to match your goals. And then contact the Electrify advisors for help on any step of the process. Okay, next slide. And then we'll leave this up while we answer your questions. But if you're interested in other aspects of home electrification, we hope you'll join us next week. All right. With that, want to make sure we get to everyone's questions. So we've got a great queue of questions in the chat, so I'll work through those and then keep putting your questions in the chat and we will answer them. So the I'll start with a question about insulation. It was, can a home be too tight if you insulate an air seal? And the solution to that is installing a ventilation systems that can pull some of that moisture and stale air out of your home to keep fresh air coming in. If you insulate an air seal without a ventilation system, you can end up with mildew issues and air quality issues because the home's tighter. So a ventilation system can look like a continuously running bathroom fan that just runs on a really low speed all the time to keep fresh air moving, or something more advanced like an energy recovery ventilator. All right. Had a couple questions about geothermal systems. The the uh, the ground loops can be vertical down into the ground or more horizontal. So those are two options. And geothermal systems typically do not need a secondary heating system because the ground maintains the same temperature year round. And then let's see, does a heat pump affect homeowners insurance? I do not have any concrete data for you there. So we can follow up, but I think that's kind of an emerging question that I imagine some insurance folks are asking themselves. Let's see here. And then we had a great question. So my furnace is only 2.5 years old, but the air conditioner is 28 years old. Is it worth it to go with a heat pump system or just replace the AC unit? So if your furnace is compatible, going with a heat pump is a great option. And a contractor can help you determine if your furnace is compatible. If it's a high efficiency furnace, like 95% plus, and it's only 2.5 years, it's pretty likely that it is compatible. So yeah, getting a contractor out to see what you can do is great. And anytime you're replacing your air conditioner, we recommend looking into a heat pump because one, it's a way more efficient air conditioner and you can heat your home with it. And then kind of related to that, it said, if my air conditioner is still working well, what would we do with it if we installed a ducted air source heat pump? The air source heat pump will replace your existing air conditioner. So you wouldn't have like an air conditioner and a heat pump because the heat pump provides cooling. So yeah, so you would, replace that existing air conditioner. All right. And I know we're at 7 p.m. I'm going to keep answering, Jason and I will keep answering questions. So feel free to stay on. But for folks who need to hop off, feel free to hop off as well. Okay. Um, Wayne asked about permits. In any HVAC upgrade process, getting permits is the standard. So that would apply to an air source heat pump and a ground source heat pump. And working with the city of Eden Prairie would be the process for both of those. Um, we had a question from Peter about how likely would a heat pump system installed today qualify for that up to $10,000 in federal and state rebates? Yeah, that's a great question. I think one thing you can do right away is to check your home's eligibility. We'll include that link in our follow-up email. Um, and then as far as how those are rolled out, we don't have the details of those yet. So what we recommend is, count on the incentives that are available today. And if it makes sense for you financially, act on what's available today because we don't know exactly how those rebates will be rolled out. And there may not be enough money for everyone to access those as well. So we recommend kind of just counting on what's available. And then, does the discount apply to all the electricity you use during heating months for the XL space heating rate? The answer is yes. So, your lights, your TV, all your electricity use qualifies for that electric space heating rate. And that is because, like we showed earlier, over 70% of all of your energy use in your home goes towards heating. So the utility thinks it's, you know, a good enough option to provide that rate for all of your usage. And then we got a question from David. What is the expected lifetime of an air source heat pump? And it's pretty much the same as standard furnace and air conditioner, which is about 20 years. You see like 15 to 22 years. Um, so yeah, it's about the same. All right. Yeah, keep posting those questions. Um, And yeah, how long would an install typically take from first consultation to system operating? That's a really great question, Peter. It can depend on a few things. If your electrical panel needs work, or an upgrade that can add some time, a couple weeks-ish. And then as far as timing, it really depends on the HVAC contractor's availability, but yeah, we do see emergency replacements where you get a new system in a couple days, and then sometimes it can take weeks to months, if you really are working through some nitty-gritty details and trying to design a really tailored system to your home. So there can be a um, pretty big range of timing. And if you are in an urgent situation, that's an important thing to communicate to a contractor because they can usually meet you where you're at. Right. Yeah. Jason, are you seeing any other questions I missed?
Let me see. Becca, yeah, we will be linking the recording, I believe. And then we'll also be sending out a PDF of all our slides. So you have those hyperlinks and various resources available. Um, I don't see any other questions.
All right.
If anybody has a question that hasn't been answered, you want to throw it back in the chat real quick, we're more than happy to respond. Thank you, Becky. Glad it was helpful.
Yeah. Yeah. Thank you so much to everyone for attending this webinar. Glad it was helpful. Please reach out to us and the advisors with any questions you have, and we'll be in touch. We're hoping this is just the first step of the journey for everyone. So yeah, we'll stick on a few more minutes for any more questions and hope everyone has a great night. And we also wanted to say a big thank you to the city of Eden Prairie again for hosting this webinar and making this possible. Thanks all.